Hello ladies and gentlemen, and welcome to another video from Accessible 3D. My name is Edis, and if you haven't watched any of my previous videos, I'm 100% blind and doing 3D design and printing. In today's video, I will be designing something from scratch, and you'll see how difficult that can be. This bag is not really a Christmas bag, but it's just a bag full of components for a big project that I'm working on. I'll not tell you what it is, but we'll see what happens when I'm done. Anyway, a couple of weeks ago, I went to IKEA where we saw one of these like kitchen board organizers, and it was very cheap, but I was like, well, I'm going to make that for a demonstration video at some point. And that's what I'll be doing in today's video. And as you can see, it's pretty long. So I hope that you will watch all of it so that you really can get an understanding of how difficult it is to work with something visual when you can't see. So yeah, sit backs. Yeah, that's a very good way of saying sit back, relax. and I hope you'll enjoy all of the video. Thank you so much. All right, for those of you who have watched my previous videos, you know that I work in Notepad, and the reason for that is I just find it easier to work in rather than using OpenSCAD itself. I'll just copy stuff in there afterwards. So I want to build this IKEA, or well, not exactly IKEA, but this cutting board organizer that I saw when I was at IKEA. And I want to walk you through the entire process so that you understand how I would do this. Now, I told you that I've seen it, I've had it in my hands, I've felt it, and so I have an idea and an image of what this will look like. And from there, I will, just take it step by step. I'll write my code and I'll tell you why I do what I do and how that works. So first of all, what I'll do here is I'll write 2 slashes and write cutting board organizer. Now what this does is that the 2 forward slashes tells OpenSCAD that this is just a comment. This is not a part of the code itself. Now I'm gonna write all dimensions are in millimeters. All right, perfect. Now, the next thing I want to do is I want to define all the base plate dimensions of the cutting board organizer. So what I'll do is I will write base length equals 234, and then I will write base width equals 100 and base height equals 10. All right. Now, what this does is that it tells OpenSCAD, all right, I need a base plate which has the following dimensions: 234 millimeters on the x-axis, 100 millimeters on the y-axis, and 10 millimeters on the z-axis. So yeah, that's the first part. Now, I also need to define the rods that will be on the base plate and that will, hold the kitchen boards, the cutting boards, and lids and all that. So what I'll do here is I will write that the rods should be rod height is 80 millimeters. Then the next thing I'll do is I will write the diameters of the rods.
Diameter equals 12 semicolon enter.
All right, and then I will write how much spacing there will be between the rods.
Rod blank.
And I will place
Rod underline. Spacing equals 32 semicolon enter.
All right, and then we need to define how many rods there will be. So what I'll do here is I will write rods
equals
7
semicolon enter.
Semicolon. All right. Now we have the rod section, or the vertical rods. So what I've done is I have written that there are 7 rods. They are 80 millimeters tall. They have a diameter of 12, and that the spacing between each rod is 32. Okay. So what we need to do now is we need to add a little bit of safety. You don't want like just flat, sharp rods. And you don't want the rods to be placed like all the way outside near to the edge. So we need a little bit more finesse, I would say. So the next thing I'm going to do here is I'm going to write edge inset, not insert, but inset 5. Now this is just to tell OpenSCAD that I want to move the rods 5 millimeters onto the plate from the edge. And then I want to have a chamfer. So chamfer height equals 5. Let's do that. And the chamfer width should be, what do you think? Should we say around 3? Yeah, let's just say that. Chamfer width equals 3. All right. And then I need to have the top of the rods to be like rounded rather than being like flat, sharp. So what I'll do is I will add a filleted top, fillet radius equals 2. So a radius of 2. All right. Now this is actually the dimensions, the part of the design that we'll be using throughout the rest of the code. So now we need to, place the rods where they should be. And now remember to comment your code, because this is pretty self-explanatory. But I will just write calculating rods placement on the base plate. Because what we need to do now is we need to calculate and place the rods where they should be. So what we now do is I will start writing the code for that, and I will explain it. Rod offset equals, what was we had those. Okay. And we will say base length and base length minus left parent again, Now, the reason why I'm doing this so slowly is because I'm reading my notes as well as I'm doing some hard calculations here. So, and just, remembering what I need to type and, um, yeah, what to do basically. Okay, so
Left parent.
we have
Space.
one
Left
left parent there,
Left parent.
one more. No.
None underline.
Rods.
Rods.
Okay, and we will say -1.
Space. Blank. Dash. Remember.
-1. All right.
1 right parent.
And don't worry, I will explain all this after
Right parent. Blank.
when
Remember.
I'm done.
Star. Remember. Rods underline.
Spacing.
Spacing. Blank. Slash blank. Full radius equals 2. Camera width equals 3. Camera height equals edge. Number equals 7. Rod spacing equals 32.
Yeah.
Contact field. Space. G. Space. Blank. Spacing. Blank.
Rod spacing. Great. And plus the diameter. Yeah.
G. Space. Blank. Plus. Remember. Rods underline. Diameter. Right parent. Right parent. Semicolon. Enter.
Okay. All right. Yeah. Whoops. That was too early with the semicolon.
Blank. Semicolon. Remember.
Need to
Slash.
divide. I need to divide this with 2. Of course.
2. Blank. Semicolon.
Now, 1 second, and I will let you know. Okay.
Blank. Rod equals space length. Number rods 1 star rod space. Blank. Slash calculated. Blank. Rod equals space length. Number rods 1 star rod space equals rod diameter slash 2.
Yeah. All right.
Enter. Rod blank.
So what this is the placement of the rods. And I want to explain what I've done here. First, I need to calculate the space that the rods will occupy. So what I have here is the amount of rods, that is 7, minus 1. That's the spaces between the rods, each rod. We have 7 rods, so we have 6 spaces. So 7 minus 1, that's of course 6. Okay. Now, we need to calculate the diameter. We need to take into account the diameter of our rods. So you remember our rod's diameter, that was 12. So what I need is, of course, 7 minus 1, that's 6, times the spacing between rods, that was 32, plus the rod diameter. So what I need to do is I need to subtract this from my base length. Now, what happens here is that, it tells us basically how much empty space I have left. And that's basically it. Finally, I need, the slash at the end of the code, /2. I need to divide it by 2 in order to distribute the remaining space evenly between the left and right sides. I have to place the rods on both the left and right side. Otherwise, it won't be able to to like hold anything. And that's, you know, that's basically what I've done here. Okay. Now, in order to like break this down with numbers, now I've just written, num underline rods and all that, and I'll tell you later why I have done it like that. But let me just give you an example with numbers. So 7 minus 1, that's 6, times 32 millimeters, plus 12 millimeters. That's 204 millimeters. Now, the remaining space is 234 minus 204. What's that? That's 30. 30 divided by 2, that's 15. So this would mean that the rods are perfectly centered, and it should give a balanced look afterwards. All right. That's the first part of the code. We've established our base. We have defined the rods, and we have placed the rods. Now, the reason why I don't use hard-coded numbers, the reason for this is because it's much harder to make a change, because like this, I would just be able to, let's say when I'm done with my code and I want to change the rod diameter from 12 to maybe 15, I could just change the number at the top of the code, and that would change it throughout the entire code. So that offers a great benefit, because usually you wouldn't just want to change, let's say, number 3 rod from the left side to have a diameter of, I don't know, 5 millimeters. So that's basically why I do this. And also, I mean, this when I share this code, it's something that can be used by others. Okay. So that's basically it. Now, the next thing I want to do is, right now I have right now I just have a base plate where, it's very sharp corners. And I want to change that. I want to have, like, these nice smooth curves that's also nice to touch, nice to the hand. So I'll just write a new comment, rounded cube. So what we need to do here is I want to create a module. And I will explain to you why I do that when I'm finished. So what I'm going to do here is I will write module rounded cube. All right. And here I will write size,
I-A-R, minimum, minimum,
radius, and then I need to have a
right
closing.
there, right there, radius, comma, size, left there, size, comma, radius, right there, minimum, left brace,
Left
enter,
brace, all right. And what I need to do here is I want to translate
translate, left there,
left bracket 0,
0, comma,
0, 0,
minimum,
0,
0, comma, minimum,
0. I think that's the best. And let me see if it, yeah. Okay, so I need to have the
left there, right
bracket,
right there,
right parent. All right. Okay. Now what I'll do is
enter,
this and let me see here. Okay, let me just add a comment.
right there, minimum,
This is just to
slash, minimum,
start
add,
build.
minimum, D, place, enter,
This is just a comment for the 3D printing part. Okay. The next command should be a hull.
left there, right there,
Yeah. Okay.
right blank,
We need to close
left
that. Wait.
left brace, enter,
Left
left brace,
brace
blank,
as well. Okay. Okay, so
blank,
here is
left brace, translate 0, module rounded cube size, translate, left blank, 4, left there,
X.
X,
Okay.
equals, minimum,
Left parent as well. Radius. Radius.
radius, S, blank, comma, minimum, size, period,
Okay. And
X,
minus
blank, minimum, dash, minimum,
radius.
radius, S, blank,
Okay. Right bracket.
right there, right bracket, period, comma, blank, for x equals radius, size, radius, blank,
Yeah. Okay. Okay. And we also need the y. The y-axis.
for x equals radius, blank,
Y
equals, minimum,
left bracket.
space, blank,
Well,
space,
I
blank,
could actually
space, equals, space, blank, space, equals, space, blank,
bracket
left bracket,
and radius,
comma, minimum, size, period,
y. Okay, you see here. Minus
slash, organizer, side up, blank, slash, blank,
gosh,
the F, y, period, y, blank, minimum, dash, minimum,
minus radius, right
radius,
bracket,
right bracket, right there,
right parent. Okay. Yeah. And
right there,
then
blank,
we
minimum,
need to enclose
left bracket, left brace, enter,
something
y,
else
blank,
here. Yeah. Yeah, I need to translate. Okay.
Blank.
Translate.
Translate. Left bracket. Left parent.
Okay. X.
And liberum.
Y.
Y comma. Liberum.
0.
0. Right bracket. Right parent.
Parent. All right. Yeah. Okay.
Translate X.
And then
Right parent. Blank.
what
Enter.
I need to do
Translate Y. Translate Y. Translate blank.
is I need to define a cylinder. Yeah. Cylinder left
Cylinder. Left parent.
left parent. All right. Okay. So
Blank. Left parent. Blank.
we have R
R equals.
equals radius.
Radius.
And okay, and we have
Space. Blank. Space S. Space. Comma. Comma. Space. Blank. H equals.
height, which is equals to the size
Equals. Blank. Size period.
Z. Yeah, the z-axis, that's the height. Okay.
Space. Z. Space.
And
Comma.
then
Blank.
what I
Space.
want to
Blank.
do is I want to add some high resolution for this. And we'll do that
Symbol.
by
Dollar.
Fn equals,
Fn equals.
let's just say 100.
100. Semicolon.
Yeah. Okay. And then we'll.
Semicolon. Blank. Zero. Semicolon.
Oops, I forgot.
Right there. Right there. Semicolon. Blank.
There. Close this off. And we have 3 right braces.
Cylinder equals translate. Cylinder.
I think it is.
Semicolon. Blank. Enter. Right there. Right there. Right brace.
Right
Enter.
brace.
Right brace. Enter. Right brace. Right brace. Right brace. Cylinder. Translate. Cylinder. Right brace. Right brace. Right brace. Right brace. Blank. Enter. Oxford 1.0. See up. Stop optical checkbox mode. For travel. See optical stop object box signal. Liberum.
All right.
Right brace. Blank.
So
Enter.
we're done with this. And now I want to just take you through what I've done here and explain a little bit about what all of this is. And I will say, as we will see later, the likelihood of me making 1 or 2 or 10 mistakes in here is quite high. I mean, it's code, and I'm not a programmer by trade, but yeah, I love this anyway. Okay, let's break this down one step at a time. So first of all, what is a module? A module in OpenSCAD is like a recipe that contains, it contains like a set of instructions. For this, for this module that I've used, it takes 2 parameters. Oh God, some tricky words. So it takes a vector, which is the size, and that contains the width, the depth, and the height of our cube. Then what it does, it takes the radius and basically tells how rounded the corners should be. All right. Now, what we do after this is that we use some of the building blocks in OpenSCAD. I guess you can call it that. What I do is I use the translate command, which basically moves the object that I'm working with. So when I say translate 0, 0, 0, it basically takes our object and places it at its like origin. Now, the next thing I do is I take the whole command, and I guess you can explain that as taking like a rubber sheet and like spreading it over or stretching it over several points. That creates the smallest, it creates the smallest possible solid shape that encompasses all the objects points inside it. I hope this makes sense. So in this case that I'm trying to build here is that it will take the cylinders and it will create the rounded cube by connecting those cylinders. Okay, so you follow me hopefully so long. Now we have something else that I've used, and it's the for loop where I've used the X and Y. What this does is that it creates 4 cylinders and places them at each corner. Okay. Now the cylinder creation part is pretty self-explanatory, I guess, because it defines the radius of the corners, it tells where to place them, and that's basically it. Oh yeah, I forgot the $FN. That determines the resolution of how fine the corner should be. So that's it. First, we place 4 cylinders at the corner. Then the whole command connects these cylinders. And the final part is a cube with rounded corners. That's basically what I hope for. Let's see when I render this in OpenSCAD how this will turn out. And this is a pretty good example of how OpenSCAD use modules and how this can be used. Okay, so let's move on. Now what I need to do here is I want to create the base. And I want to create the base into a module. And the reason for that, well, somebody could reuse this module. So I will declare base.
Base left parent. Right parent. Middle room.
Parent.
Left brace. Enter.
Okay. And you remember what I talked about previously? That instead of using hard numbers, I will do the following.
Module base left line.
Rounded
Rounded underline.
cube.
Q E. Blank E. Blank. Left parent. Left parent.
Left parent. 2 left parents. And oops, now I see I made a mistake. It should be a left bracket. Got it.
Left blank. Left parent. Blank. Left parent.
I was about to curse, but
Left bracket.
I'll refrain
Left bracket.
from
Left
that.
parent. Left blank.
This is a pretty new YouTube channel, so I hope that it will stay a little longer online if I refrain from cursing. Now,
Left blank. Left blank.
what I'll do here is base
underline.
length,
Length comma. Middle room.
base
Base underline.
width,
Width comma. Middle room.
and of course, base height.
Blank. Space blank.
Base
underline.
height.
E. Right bracket. Middle room.
Bracket. And
Space, right bracket, space, comma, space, blank.
5,
Five, right there.
parent,
Semicolon. Enter.
semicolon. The semicolon, I don't know if I mentioned this, but that kind of tells OpenSCAD that that's where I end. That's the code. All right. And we need to close the module
Blank. Round the cube, blank.
as well with a
Right bracket. Right bracket. Right brace.
right
Enter.
brace.
Right brace, blank. Enter.
Okay, so let me explain what I've done here. So first of all, of course, I declare the module. And, you know, it creates a new module that I call base. And that's basically what I do there. Now, inside the module, I call the previously created rounded cube. First, I pass it one argument, that is the base length, base height, base width. And secondly, I call the radius of the corners, which is the 5. And yeah, that's, you know, that's basically what I do. And remember that I told you before, instead of hard coding the numbers, I use the values that you know we've created before, so that I could change the variables at the top of the at the top of the code if I wish to do so. Okay. Now, what I want to tell you as well is that, like, you know, the square brackets tells OpenSCAD that the numbers should be treated as like a single unit. And yeah, basically the number 5 tells OpenSCAD that the corner radius should be 5, and this should be enough to remove any sharp edges, corners, whatever. Now, again, the reason why I create a separate base module is because, well, this could be reused by others if they wanted to. Now, this is not too complex, so I'm not really inventing or doing anything crazy. It's just like, you know, it's just basically to demonstrate how this can be done. Okay, that's it. We're getting there. However, now we need to create the most, I think, the most complex or difficult or whatever part of the code. And that is the rods with chamfers and fillets. So what I'll do here is I'll just type rods with not a chamber, chamfer and fillet. Okay, and again, I will just type the code, and I will tell you what I've done and how and why afterwards. Okay, first of all, I will create a module for this.
Module. Rod underline. With underline. Camera underline. And underline. Fill left parent. Right parent. Middle.
Okay, and
left brace.
Left brace. Yeah. Okay.
Enter.
Now you'll see something else here. And that is the union.
Union left parent. Right parent.
The union command. and I will explain what
Right there.
that
Blank. Middle.
does.
Left brace.
But
Enter.
this is one of the few things that actually make very good sense uniting something. Like translate, I mean, translate, it's kind of interesting why they just didn't call it like move. I mean, that would make much more sense in my head, I think. Okay, so union. And then we also need
Unit blank. Unit left blank.
a difference
Difference left there. Right there.
command,
Middle. Left brace.
which also kind of makes good sense because like it means the difference between one part and another. Okay. And then we need
Difference left brace. Unit left brace. Module with unit left difference blank.
one more union.
Unit left there. Right there. Middle. Left brace. Enter.
Yeah. Okay. So we have the difference command, the union.
Blank.
Yeah. Okay. Okay. Cylinder.
Silver left there. Rod underline. I-G-H-E-I-E-H underline. Underline. I comma. Middle.
Cylinder rod. Yeah. Okay. I forgot that. H. Okay.
Comma. I. Underline. Rod. Left there. Rod. Left there. R.
H.
H equals. Equals. Rod. Underline. I. Comma. I.
Yeah.
Comma. Blank. Space blank.
Okay. And then let's see here. Okay. D.
Blank.
That's
Equals.
diameter.
Rod underline. Diameter comma. Middle.
Yeah. And we'll set the
Dollar.
to
FN equals.
100. And we will close it off.
100 right there.
That's
Semicolon. Enter. Cylinder equals rod height equals rod blank. Cylinder left there. Cylinder left there. H equals rod underline height comma D equals rod underline diameter comma dollar FN equals 100 right there. Blank blank.
yeah.
Cylinder blank.
Okay, that's good. Sounds good at least. Now what I need to do here is translate.
LSNRT. Translate left there. Left brace. Left brace. Left bracket. Zero comma middle.
Let me think. 0, 0, and that should be
Space blank. Zero comma middle.
wrong
Rod underline.
height. Okay, it's good. And I need to withdraw.
IT blank. T blank.
Withdraw the fillet. Yeah.
Blank. T blank.
Need to
Middle dash middle.
withdraw the fillet
Fillet.
radius. And then we close it
Blank.
off
S blank.
with
Right brace. Right brace. Right bracket. Right there. Right there. Blank. Enter. Translate 0 0 rod height fillet radius. Blank.
Yeah, that's good. Okay. Then I will create a torus.
Torus left there.
And you might wonder what that is. I'll tell you. Okay.
Left blank. Left blank. Left there. Blank.
I need to take the rod
Rod underline.
diameter
Diameter slash.
divided by 2.
2 comma middle.
Yeah. And that's minus
Middle comma. Middle dash middle.
fillet
Fillet underline.
radius.
Radius comma. Middle.
Yeah. And that's one more time.
Side up right brace. Right brace.
Wait.
But fill space. Blank.
See, that's like, I just accidentally pressed the side up, and if I didn't notice that, I could
Space blank.
start typing
Fillet underline.
somewhere like different in the code, which is, well, that just wouldn't be good.
Blank. S blank. Right parent.
Parent.
Semicolon. Enter. Torus rod diameter blank. Torus rod diameter slash filter radius. Filter radius. Blank.
Okay. Okay. Yeah. And I need to close
Torus blank.
this.
Right race. Enter.
And,
Right race. Blank.
and then I need to translate.
Blank. Right race. Blank.
Translate.
Translate. Right parent. Right parent. Left parent. Left race. Left race.
Damn it.
Left bracket.
Oops.
Left bracket.
Beep.
Left bracket.
0.
0, comma, middle.
0 as well, I think. Yeah.
Space. Blank.
0.
0, comma, middle.
Raw.
Rod underline.
Right.
Height. Right bracket.
And
Right parent.
yeah. Okay. Let's see. Okay.
Blank. Right parent. Blank. Enter. Y. T.
Cylinder.
Silver. Right parent. Right parent. Left parent.
Left parent. Sometimes I need to move my clumsy fingers.
Blank. Left parent. Blank. H equals. Fill underline. Radius. Top. Middle. D equals. Rod under. Diameter. Comma. Middle.
And I need to take
Blank. Space. Blank.
make it
Dollar.
smooth. And then one. Oops.
One, 0, 1
equals.
Equals. 1, 0, 0. Blank.
Fn equals 100. Yeah, that's fine. And then we need to close this.
Blank. 0. Blank. Right parent. Semicolon. Enter.
Okay. All right. And I need to close
Blank. Silver. Blank.
this as well.
Right parent. Right parent. Right race. Enter. Right race. Blank.
Yeah. Okay. I need one more translation.
Right race. Blank. N-A-R-T. Translate. Left parent. Left bracket.
Left bracket.
0, comma, middle.
Yeah. Okay. And
Space. Blank.
that's the 0.
0, comma, middle. Dash. Middle.
Minus the chamfer height.
Blank. Middle. Dash. Blank.
Chamfer
Camber underline.
height.
Height. Underline. Camber. Dash. Comma. 0, comma, 0, comma, 0, comma, dash. Camber under height. Blank.
Yeah,
T. Blank.
this is correct, I think, at least. And we close this. Translation.
Right parent. Enter. Translate. 0. Blank.
Yeah. Okay. Okay. And then we need another cylinder.
I. Y. T. Silver. Left parent.
Mm-hmm.
Left blank. H equals.
Chamfer
Camber underline.
height.
Height, comma, middle.
Yeah. Okay.
Blank.
Diameter 1.
D. Blank.
And that's
1
equals the raw diameter.
Equals. Blank. Rod dash. Diameter. Plus. Plus. Blank. Plus. Blank. Middle.
2. Okay.
2. Blank.
And that's
Star.
where the chamfer
Camber underline.
width.
With comma. Middle.
Okay. And then we have the D2, second diameter. D2.
D2. Diameter underline. Height, comma. Middle.
Oh, what the heck am I just writing there?
Comma. Blank.
Hold on.
Comma. Felt. Height. Felt. Underline. Diameter. Felt. Equals. Marker. Equals. Blank. Equals. D2. Equals. Blank.
Rod
Underline.
height.
Height, comma. Middle.
Diameter height. What the heck? You know, sometimes when I do a lot of this coding, it's like, you know, when you write a book or whatever, you will inevitably do some wrong typing. Okay, rod, and it's not the height I need here.
Height, THGIE.
Of course, it's the diameter.
Diameter, length, space length.
All right. And I will add another
Space length.
FN
FN equals
100. That's it. And let's close this.
100 length. Right there. Semicolon. Enter.
Okay. All right. And we also need to close this part.
Right bracket. Right bracket. Right brace. Enter. Right brace. Length.
Like this. Okay. And to close everything off.
Right length. Right brace. Length. Right brace. Enter. Right brace. Length.
Right brace. All right. Whew. Okay. This is, let me just walk.
Right brace.
Let me just have my screen reader read.
Right brace. Tilde trans. Right brace. Tilde trans. Right brace. Force trans. Tilde in difference. In module rod length. Slash rod with length. Module rod with camera includes left brace. In left brace. Difference left brace. In left brace. Tilde equals rod height. Equals rod diameter. Dollar equals 100. Translate 0 rod height tilde radius. Force rod diameter slash tilde radius. Tilde radius. Right brace. Translate 0 rod height. Tilde equals tilde. Translate 0 tilde right brace. Tilde equals tilde radius. Equals rod diameter. Dollar equals 100.
Yeah.
Right brace. Translate 0 camera height. Tilde equals camera height. D1 equals rod. Right brace. Right brace. Length.
Okay. All right. Let me just explain a little bit about OpenSCAD operations. The first thing, union. As I said before, Unity combines multiple it combines multiple shapes together. Now, the difference operation subtracts the second shape from the first. And translation moves shapes to a certain point on your object. Okay. I told you about the cylinder. You know what that is. That's pretty self-explanatory. The torus creates a kind of like a ring shape. Okay, so let's break this down. Now, the first thing I want to tell you is like the main structure of this, which is that the first union combines two parts. That's the upper part of the rod with its rounded part, and the lower part of the rod with the chamfered base. Now, the second thing that happens is like the upper part, which is inside of the difference operation. What that does is first of all, it creates this main cylinder for the body. Then it creates like this torus on the top. And that's for the rounded edge, yeah. Then what it does, it subtracts a small cylinder at the top to create like this rounded edge. Then we have the lower part of this design, which is the chamfer part. Now, what that does, it kind of creates this conical, well, not kind of, it should create, what I'm trying to create is this conical shape at the base that should start like wider at the bottom, which is the reason why I use the D1. And it narrows to match the diameter of the rod top, which is the D2. Okay, so that's basically what this is. You also notice that I use a lot of these $FN, which is like smoothness control. And I just want to mention that the higher numbers you use, the more computational resources this takes. The reason why I created the chamfer at the base is because this should make the rods more stable. And it should also provide this like smooth transition to the base. And also, well, from a blind guy's perspective, it should look a little bit more like pro, you know? So that's it, the filleted top. It removes all the sharp edges. It creates like, if I like bump my hand down on it, I won't like get stabbed or anything like that. And it adds a kind of, you know, nice touch, nice finish. Okay. Yeah. So that's basically what happens. Now I just want to tell you a little bit about like the dimensional calculations. So the rod diameter plus, that's kind of a mix between Danish and English, plus 2 times chamfer width. That's a calculation of the wider base, and that's of the chamfer part. Then what I do is I multiply it by 2 because we're adding like the width to both sides. Then what we do is I use the rod diameter divided by 2 minus the radius of the fillet. That's a calculation for the position of the torus part. Now, what that should do is it should ensure a perfect alignment with the rods, the surface of the rods. We'll see what happens when I print this out. So that's basically it. And this module, well, I think kind of demonstrates the more advanced, like not really advanced, but like for someone who is completely new to OpenSCAD, this might seem like a bit of like, it's much. I hope I managed to explain it like properly. Okay. Now what I want to do from here is I want to create a torus module like that. I can reuse it all the time.
Module. Enter.
Okay. So what we do, we of course need to make this module. We're used to that at this point. Module torus. Okay, and I need to have this within the, yeah, that's right, R1, which is the radius. And then I have the, let me see here, R2. R2D2. No, that's a joke. Don't write R2D2 anywhere, please. Okay. And oops, I need to have this within a left brace. Okay, now
Blank modules blank.
do rotate,
Rotate underline. R T.
extrude. Okay. And I need a lift
E
parent.
blank. E blank. Left parent.
Convex,
R E T.
convexity. What should I make that? That's like
Blank. Y blank.
convexity
Equals.
equals, let's just say 10,
10 comma minimum.
which is good. And I will add some smoothness control
FN equals.
to that. F1 equals 100. And I will close that off.
100 right parent. Enter. Rotate extrude convexity equals 10. FN equals 100. Blank.
Yeah, great. And then we need
Rotate blank.
some
N A R T.
translation or movement,
Translate left parent. Left bracket.
if you will. R1. Need to move that. And then
R blank. 1 blank. Comma minimum.
I don't need to move
0 comma minimum.
the y-axis. And on the z-axis,
State blank.
neither.
0 right parent. Right parent. Right bracket. Right parent.
Right parent. Okay. So
Blank. Right parent. Blank. Enter.
I'll create a circle.
Circle left parent.
Parent. Okay, and that's
Blank.
radius
R equals.
2. Okay.
R2 blank. 2 blank. Comma
And
minimum.
I'll
Dollar.
put that
FN equals.
100. Okay. And then I will close
Then
this
0
off.
blank. 0 blank. Right parent.
Right
Semicolon.
parent,
Enter.
semicolon.
Circle R equals R blank.
All right. And then I will close off the module.
Blank. Circle R blank. Right parent. Right parent. Equals. Equals.
Oops.
Right race. Enter. Right race.
Let
Circle R
me
equals.
just read this.
Translate R1. 0 0. Rotate module blank. Module force R1. R2 left race.
Yeah.
Rotate extrude convexity equals 10. FN equals 100. Translate R1. 0 0.
Okay.
Circle R equals R2. FN equals 10. Translate R. Circle R equals R2. FN equals 10. Right race.
Yeah.
Blank.
Okay.
Start 31. Start first. See optical stop pause. Take off. Take minimum. Baby marker. Start.
Okay, so we're done with this
Blank.
part.
Blank. Blank. Blank.
And I want to explain as well with this what I have done. So first of all, we have the module declaration. What it does is it takes two parameters. The first one, R1, which is the major radius. That is the distance from the center. And then we have the minor radius, which is R2. And that's the thickness of the ring. Okay, so here we have introduced a new rotate extrude command. And what that does, the part where it's like rotate extrude convexity 10, it takes a 2D shape, not a shapes, and it spins it around the center axis. And the convexity equals 10 helps OpenSCAD to render complex shapes correctly. So yeah. And you know the dollar, FN, smoothness control. Now, we also need to position the circle. The first one, the translate R1, that moves our 2D circle away from the center point. And the distance move is the R1, the major radius. Basically what that does is it determines how wide our torus will be. Then what we do is create the basic shape. That's the circle. And that's a 2D circle, which will be rotated. And the R2, it sets the circle's radius, the minor radius. And of course, again, takes the smoothness control. All right. So the question is now, how does this actually create the shape? The first part of this is that we create a small circle. And that has the R2 radius, the minor radius. Then this is moved R1 away from the center. Then what we do from there is we spin this circle around the center point. It's like, taking a pencil and spinning it around the center point while it draws. I think that's the best way I have had this explained to me. So kind of makes sense to me. And what happens is we have a donut shape. So yeah, I guess that's the best explanation for this. So the application of this is that in this design, it creates smooth, rounded edges on the rods. It makes the design more smooth and more safe, and also adds a visually appealing perspective. Yeah, all right. Maybe we should move on to something a little bit like, it's kind of a nice little touch. And that is, I want to add some text to this design. And we'll create a module for that as well. But first of all, we'll create an obligatory text comment. And we'll say text edit. I'll just write my name on this. Okay, so what we'll do from here, we'll make a module called name text, and we will, I don't want to push my notepad down. We will add a left parent and a right parent and an open left brace, just like we've done with all the other modules. Okay, so what we need to do is we need to determine the text height. And what should we say? That will be like 5 millimeters. That way I can feel it. Next underline height 5. Okay. And then we will take the font size. Let me just type that font size equals, and we'll take that to be around 20. That should add a good, it should be pretty like touchable, feelable, whatever you'd like to call it. And also it should be visible. So what we'll do here is we will translate left bracket, and we will do base length divided by 2, and then we'll take the width as well.
Base underline.
Base on, and just divide that. Divide that with 2.
TH. Blank. Slash.
Yeah. All right.
Blank. 2. Blank. Comma. Middle room. Base underline.
Okay. And then we will close
Right
this.
blank. Blank.
Wait.
But field. T. Blank. Right bracket.
Right.
Right parent. Enter.
Parent. Great. Now we will do another interesting command. Linear
Linear underline.
extrude.
Extrude left bracket.
And we will remove
Left
that
parent.
height on the right height. And that should be equals the text height.
Blank. T. Blank. Middle room. Right parent. Right parent. Equals. Middle room.
Text
Text underline.
height. All right. And we will close
Blank. T.
that.
Blank. Right parent. Enter.
All right. Now we need to write the text. Text.
Text left parent.
Wait, not
Add.
a quote. Yeah. And then we will write my name here.
Quote. Blank.
Edis.
Edis quote.
Yeah.
Quote. Blank. Comma.
Comma there. There we go. All right.
Linear extrude height. Text edis. Comma. Blank. Enter.
Okay. Now we need to determine the size of this, which should be
Equals. Middle room.
the font
Font underline.
size.
Size comma. Enter.
Okay. And then we need to
Size
take
blank.
the font.
Equals. Middle room. Add. Quote.
Which type this should be? Liberation. We'll just use that.
Liberation.
Sans.
Sans colon.
Okay, and this should be this
Size equals.
bolt. Not bolt.
T.
Should be bold. Okay. And we
D. Blank.
close
Quote.
this.
Comma.
All
Enter.
right. All right. All right. And then we need to
Equals. Middle room.
align this, align, and make it the center.
Center comma.
Yeah. All right.
Blank comma. Blank. Comma. R. E. R. Comma. Quote. Quote. Comma. Blank.
And then we need to make a Valen or Valine or however you would actually pronounce this.
Equals.
Valine, and this should also be centered. Yeah.
Blank space. Blank. Quote. Center quote. Comma.
And then we need to close this off.
Blank. Comma. Blank. Comma. Quote. Comma. Blank. Comma.
Whoops, like this. Yeah, okay, I need to.
Quote. Blank. Right there. Semicolon.
There we
Enter.
go. And what we need here is the final part for this
Blank.
module,
L equals blank.
and that is
Right brace.
right brace.
Enter.
Okay,
Right blank. Enter.
so let me explain what this does. First of all, we have created a new module called text edis. I think we called it that.
Size equals text edit. Linear translation. Linear text module slash text module name text left brace. Slash module name text left brace.
Name
equals size.
text. Okay,
Blank. Blank.
that's our module. So we define this as the height of the text is 5. That's the height of the extrusion. Then we have the size of the font, which is 20. Okay. And this is quite interesting because I've made it so that this is only made within this module, which means that you can basically adjust the text and size and font without adjusting any other code. Okay, so the positioning of the text is I've placed it on the half of the base length and the base width, which should place this in the middle of the plate. And that's sometimes, all of this rotation and movement part for my part is pretty difficult. Because, you can see how this is. If I just mistype a little thing, it won't do what I expect. Now, what we do here is we create 3D text. That's the linear extrude command. And we extrude it so that it's 5 millimeters so that I can feel it. And what this does, it kind of converts 2D text into 3D. Okay. And then we write the name, Edis. You could do whatever you want here. And what we do is we take the Halin and Valin, or Haline and Valine. What that does is the Halin part centers the text horizontally, and Valine centers the text vertically. And yeah, that's basically it. What Halin does is it places the text horizontally from both left to right, like in the middle. And it ensures that the text stays there regardless of how wide your base plate is. And the vertical alignment, it kind of does the same, just top to bottom. And again, you can change the width, the width of your base plate without doing anything else. So, is there anything else I should say about this? No, I don't think so. Sometimes, you have to experiment with this a little bit, because how high should the text be to be feelable? Do you want to make it extruded or engraved? You have some different options you can play with. Okay, so we're almost done with this. Now, the next thing we'll do is that we will make a comment. Placement of rods. So what we'll do here is we will start placing the rods. And that can be difficult, but we'll see how it goes. Module. And what should we call it? We should call it place rods, I think. Yeah. Place rods.
Rods right there. Minimum.
Remove this.
Left bracket. Left bracket. Left brace.
Make
Enter.
this left brace. Okay. So what we do here is we write 4.
Left parent.
And then let me see.
Left blank.
Side.
Side. Right parent. Right parent. Equals. Minimum.
Equals. We have a
Left bracket.
0,
comma.
comma,
Minimum.
0, comma 1. And
1. Blank.
close this.
Right bracket. Right parent.
Yeah. And then we
Blank. Right parent. Blank. Minimum. Left brace. Enter.
left brace. Okay, we need to translate this.
Translate. Right parent. Right parent. Left parent. Left bracket.
0. Okay.
0. Blank. 0. Left bracket. 0. Blank. Comma. Minimum.
Side. And then we need to
Blank. Space. Blank. Star. Minimum.
honor this,
Left parent.
or times as it's also called. And this is
Blank. Left blank.
the base
Base underline.
width. Okay. And that's
Blank. Base. Blank. Minimum. Dash. Minimum.
minus 2
2. Star.
edge
Edge underline.
and set. Okay. I think. And then we minus
Blank. T. Blank. T. Blank. Minimum. Dash. Minimum.
this from the rod diameter.
Diameter. Right parent.
Close this. Okay. Okay.
Right parent. Blank. Comma. Minimum.
And then base
Base. Height. Underline. Base. T. Height. Blank. T. Blank.
right
Right bracket. Right parent.
parent. Yeah. Okay.
Right parent. Blank. Enter.
That's good. Okay. Okay.
Blank.
Forward.
Right parent. Right parent. Left parent.
Okay.
I. Blank. Minimum. Equals. Equals. Space. I. Space. Equals. Blank. Minimum. Left parent.
Yeah. Let me think here. Okay, that's
Left parent. Blank.
0.
0. Colon. None. Underline.
rods. And minus 1.
Blank. S. Blank. Dash. 1. Oxford 1.0. Start first. See optical stop object. Activity marker. Minimum. Baby marker. 1. Blank. 1. Blank. Right parent.
Whoops.
Right parent. Right bracket. Right parent.
Parent. Okay. And then we need to.
Right blank. Minimum.
Let me think here. Yeah. We
Left
need
brace. Enter.
brace. Okay. And then we need
Right
to
blank.
translate the offset.
Translate. Left parent. Left bracket. Rod underline.
Offset. Yeah. Okay, that's
T. T. Blank. Minimum plus. Minimum. I.
Times.
Blank. Space. Blank. Star. Minimum.
That's the rod spacing.
Space. Blank. Rod underline. Spacing. Comma. Minimum.
Wait.
Comma. Spacing. P. A. C. I. N. T. Comma. Space. Blank.
That's good. I spelled it correctly. Okay.
Blank. Space. Comma. Space. Blank.
Edge.
Edge underline.
Inset.
Edge.
Yeah. And then
Space. Blank. Space. Blank. Plus. Middle. Rods underline.
We need to
Diameter slash.
divide that by 2. And
2. Blank. Comma. Middle.
0. Yeah. And
0. Right there. Right. 0. Right. Blank. Enter.
all right.
Translate round blank.
Okay. All right, let me see here.
First module blank slash list with the rods blank module is rods left race blank slash blank right race blank slash blank module is rods left race for sub trans right translate round plus blank trans blank.
Great.
Blank.
We need to see
Rods underline with underline M-A-T underline
Wait.
underline
For
camera underline and underline. Tilt blank T blank left there right there
Okay.
right there blank semicolon enter.
All right. And we need to close this off
Rod blank rod with blank
with
rod with camera blank rod with camera blank right bracket enter blank right bracket right race enter right race enter right race enter right rod translate rod for translate 0 for site equals 0 1 module is rods left race blank slash left list with the rods blank right race value equal right blank slash blank module is rods left race for site translate 0 site star for site equals 0 1 left race translate 0 site star basement star engine rod diameter base height for site equals translate rod with right race.
I'm just reading through
Right,
this, and I think we're done with this part. Okay, let's explain this. There's a double loop structure here. So let me just explain that briefly. The outer loop, that's the first one, where I write for side equals 0, 1, and then what this does, this is the creation of two sets of rods, 2 rows, front and back. The first row is called side equals 0. Then the other is side equals 1. So that's what happens there. Then we have the inner loop, which is the part where I write for I 0 num rods. And what this does is that it takes these individual rods and places them along each row. And it runs from 0 to num rods minus 1. So what this means is that we have 7 rods, and this means that this runs from 0 to 6. All right. So let me break down the translations for you, or the movements. The first one, the row positioning. I hope that the part where it says translate 0 side times base width minus 2 times edge inset minus rod diameter and base height. What this should do it should position each row of rods. X equals 0 starts at the left edge. Y calculates from front to back. And the height part should start the rods at the top of the base. All right. The Y calculation is base width, and that's the total depth of the base. The part where it says 2 star edge inset, that takes in account like the margins on both sides. So you know where I talked about previously that I didn't want it to start like right at the edge. The rod diameter accounts for the rod thickness, of course. So yeah. Then we have the individual rod positioning. We have the translate rod offset plus I star rod spacing. And then we have the edge inset plus the rod diameter divided by 2. What this does is that it takes each rod and position them within their respective rows. Yeah. So here we should have 2 sets of rows placed correctly with a small margin on both sides. And yeah, this should work pretty well. All right. We're almost done with this. I'm almost done with this. You can already see how much time this takes, let alone making like a huge, like as I demonstrated in the first video, it's a lot more complex code, and yeah, it takes days rather than just hours. All right. The last part, we need to assemble all of this and render it. So let's do that. Okay, so I will make a comment which is called main assembly. All right. So we need to assemble all of this into one cohesive, hopefully model. And we will call this new module kitchen organizer. Left parent, right parent, and then we have the left brace. All right, let's see how we can do this. We take the difference, left parent, right parent, yeah, and we also have that here, and then we have a union. Yeah, and left brace. Okay. So we have the base. Great. And we need to have a semicolon there. And then we just have the place rods
Rods left parent, right parent, semicolon, enter.
Great. Then
Please rods,
we use the module name
name under,
text.
text left parent, right parent, semicolon, enter.
All right. Let me see. Have I forgotten anything? And then we have a. We need to close
Name text, name.
this.
Right race, enter, right race, blank.
Then we translate.
Blank, left parent, slash,
Okay.
slash, left bracket,
Okay. One.
1, comma. Forward 1 F9, forward member, picture until net, escape 4 member, text editor, comma, size, comma, blank. Font equals liberation chance, size equals font size, but fill, family 1, comma, 1, comma, blank.
Okay.
Minimum.
One.
Dash.
Oops. Hold on.
Minimum.
I'm doing this
Comma, 1,
wrong.
comma, 1, left bracket, blank. Dash.
Yeah. Okay.
1,
Here
comma.
we go.
Minimum. Dash.
Minus 1.
1, comma, minimum.
And then
Blank, space, blank. Dash.
minus champ.
D. Camera underline.
Height. See here.
D. Blank. Dash.
1.
1, blank.
Close this.
Right bracket, right parent, enter.
Yeah, all right. Then we take a cube,
Cube left bracket.
left bracket. Base.
Blank. Base underline. Length plus 2, comma, minimum.
Let's see. All right. And
Space, blank, space, blank.
base.
Base underline.
Width
Width plus
2.
2, comma, minimum.
Okay. And then we have that one more
Space,
time.
comma, 2, plus, width, underline, base, base, under, width, plus, valt, 2, valt, comma, valt, copy your valt, D-A-S-E, underline, plus, base,
Copy
plus, 2,
this.
comma, space, blank, space, blank.
All right. And then we have the chamfer
Camera underline.
height
I plus,
1. And then we close this.
right bracket, right parent, semicolon, enter.
Semicolon. Okay. And then
Cube base, blank,
we
right race, enter.
close this.
0, enter.
Close this. Wait.
Blank, 0. Right race,
Close
enter.
this.
Right race, blank.
Have I gotten all? Yeah. All right.
Right race, blank. Right race, blank.
And
Enter.
then
Slash, minimum.
render
Render,
the
Model, enter.
model. Okay. And we'll take,
Slash, blank.
let's say,
Dollar. FN equals 200, semicolon, enter.
we'll just take a high resolution. Okay. Yeah, did I write it correctly?
Blank, semicolon, slash, dollar.
Kitchen
Underline.
organizer. Yeah.
Organizer, left parent, right parent.
All right. Let's see here
Semicolon.
what will happen. Let me explain this last part because we're almost done. First of all, the kitchen organizer module. That's
that's the main module where we combine all these elements that we've worked on. It's almost like, you know, the final assembly line in manufacturing. It should bring everything together. We'll see when I render it shortly. Then we have the components. Well, the component union, where we add things together. We add the base, place rods, name text, and that's what it combines. You remember when I talked about unity? And remember, order matters. It's built from the bottom to top. That's why I take the base first. Then we have the difference part. So what that does is it creates a clean bottom edge. And the translation part moves the cutting cube. All right. Let's see what will happen, because the last part is of course the final rendering command. Now we have the entire code here. Let's see. Now what I'll do is, if you watched my previous video, I'll select everything, copy it, and then I will take OpenSCAD, here. I'm just waiting for it to load. For some reason, OpenSCAD can be very slow, and it shouldn't be my computer because it is a pretty good computer. All right, here we go. Let me just maximize. Oops. Yeah, there we go. We'll place my code here, and we'll press the F6 command to render. And I have an error. Let's see if we can fix this. I'll open the error log. On line 26, I have a syntax error. Let me jump back into the notes block, and I will try to find line 26. Let me see here. Is that? Okay, hold on. Okay, I just had to connect my laptop to some charging power because it almost ran out. Line 26. Hold on. Let me see here. All right, so what I'll do here is
Up 31. Up.
I will have.
Untitled bus tabs are open tab. For click to left on Untitled bus tabs are error.
I will just
Enter for
have.
click member. Click the log of W. Enter for your menu. Val 21. Copy.
I might as well make it easy for
Up
myself.
31. Start cutting board organizer national slot. Open tab 2024.2.2. Untitled bus tabs are open tab. Up 31.0.1 Bravo.
I will have
Stop up checkbox markers. See up
Chat
Stop
GPT
up.
over here.
Overhand combo limiter. Color list box. Senior list box. No slot. Free app. Browser. Tab.
Okay.
Windows M. Scribbler. Mud 34 F 34. Google Chrome 13 F 34. Mud 34. Google Chrome 30. Enter.
Here and here.
Chat enter. Chat GPT and Google Chrome. Chat GPT and Double up Bravo. Send this still over script like member. Send this still chat enter. Main region. Send this still chat GPT in this text. Is number T. Sort blank.
What is the error on line 26?
Skip enter. See enter. Virtual PC. Read the articles over article. Articles over script slash cutting board.
Let's see here.
Read the articles circle bullet. Translate 0 over script over errors. Like met number 1. Undefined variable P. Chat GPT or static and like met number 1. Undefined variable P. Like met bullet variable P is not declared anywhere in the code. Like met 1. Like met over script over errors. Translate retype your map. Translate 0 P slash start of the build place. Chat GPT or static and edit.
Oh,
Retype code your tab. Code your map. Tab. Your open tab script contains multiple syntax errors, but the specification on line 26 is chat GPT or static and over script 06 chat GPT tag. Your open tab. Code your map. Retype your map.
this is probably a typo I did
Translate
somewhere.
0 P slash start of the build place. Chat GPT or static and edit. Up 31.0.1 Bravo. 89 to 89. Browser scene. Left. Cat.
Let's see here.
Browser scene. Left. Cat scene. 1 F6. No slot. 3 F6.
Note
Untitled bus tabs are open tab. Start cutting board organizer dash no slot. Start cutting board organizer. Top F field slash control key. Link number dialog. 1 for navigate your tab. 26. Dot enter. Text editor program edit in bold text. Color phrase. Trace equal radius. Size radius. Color trans module around the two top.
Now this can't be true.
Up 31.0.1 Bravo. 89 to 89 for click to left on title test room.
Hold on.
Up 31. Color. Limit. See up. Filter filter over. Siren. Stop up check. See up stop object box enter. Start cutting board. Open tab code deep. Untitled bus tabs are open tab. Window W enter E. Escape for your menu enter blank 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 blank. Start cutting board. Open tab code deep. Open tab 2024.12. Untitled bus tabs are open tab. Menu W enter for click member. Control C. Enter E. Enter for your menu. Copy your text. Up 31.0. Start cutting board organizer. Open tab code deep. Open tab 2024. Up start cutting board organizer. Open tab code deep. Control L. Open tab code deep. Folder. Link by over script over. Escape like met lever. Control L. Escape over script like met lever. Open tab code deep. Alt F4. Slash cutting board. Windows M. Mud 34. Google Chrome. First enter. Address box legit. Pause enter. Pause and Google Chrome. Pause and Google Chrome. Stop. Read the section start. Go in provision. Edit in bold text enter. Blank 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 blank. Is said that there is a syntax error line 26 letter. Please LLET correct this file correct file please blank tell me what the error is called skip enter see enter virtual PC upper user choose clause 3.5 on the foldder read link clock kitchen $1 equals kitchen organizer link clock enable save wait in line kitchen wait in line like met level line 26 careful like met 1 base length is dispelled line 3 base length 2 1 base length is dispelled line 3 period base underline length ER blank 1 period like met 1 base length is 2 on line 26 there's an error in the root syntax like select copy map for equal radius size radius slash error here the issue with the parentheses and bracket combination no stand the correct syntax for root should use square brackets to define the range it should be copy map for equal radius size radius additionally there are a few other syntax issues in the code that you might want to fix like met bullet line 27 the closing bracket should be a square bracket bullet line 28 translate x y 0 is a smash bracket edit enter sort blank please correct all errors and give me the complete code enter virtual PC read the link clock please correct all errors and give me the complete code link clock complete correct all EA please correct provide the correct version of the open tab code for your cutting board organizer over script over untitled untype 89 with 0 map over script 89 with 2 map 1926 89 choose clause 3.5 on Summers map Google capture screenshot of read the section blank read the sections blank reply to read the section link clock enable preview content map I will provide the correct version of the open tab code for your preview link clock enable preview content map I fixed all the syntax errors and issues in the code here are the main corrections I made like met 1 fix the spelling of base length to base length 1 fix the spelling of base length to base 2 correct the root syntax around the cube module 3 fix the mismatch brackets to the translate function 3 fix the mismatch brackets to the translate function 4 correct the base to base size 5 fix rod 4 correct the base to base size 5 fix rod diameter 6 add missing dollar prefix to f equals 100 7 remove 6 add missing dollar prefix to f equals 100 7 remove unnecessary variable p around the cube module 8 fix bracket syntax to parentheses 9 correct the dimensions of the final cube fraction 10 properly indent the code for better readability like select the code should now work correctly in open stand to read your cutting board organizer with publish 89 with 4 enter 89 untitled bus tabs are edit in this text enter E enter folder blank blank see the file book folder F6 Chrome side clause 89 untitled bus tabs are edit control error log L enter folder semicolon control error log L enter for clause alt F4 table up 31.0.1 Bravo 89 up stop up stop pause lemon baby margaret optical stop object CD markers. For failed level BD markers.
I'm gonna
OpenSCAD 1.0. OpenSCAD 2000. OpenSCAD 2000.
close
Windows 10
this.
Alt 4. Option 1.0. Windows M. Scribbler. Bud 34 F 34. Google Chrome. Enter.
Google
Master
Master Print.
Enter. 3D printer management. Remote control Wi-Fi browser. 3D manager toggle. Basic blank. Light basic leader account. Use. Enter. 3D virtual PC
There
mark.
we go.
Astro Center over launch basic design library basic over script over link. Enter. Astro
Design
Center.
library.
1931. Design test STL over script over link. Failed file. Enter.
I'm gonna choose
80 valve readability. 80 valve test. Enter.
test.
Design library. Yes. Virtual PC marker. Design test 1 STL over
All right.
0% 5 link print. Map menus and folded. Enter. Map print link. Slice link. Enter.
Slice it. And
Option 1. Stop obstacle checkbox. Start CD. There edit. Overhand combo box. Link picture. Color list box. Astro website. 1F3. 4. Senior list box. Astro scene. 6F6. Astro print 5F6. Design Astro print register. Virtual PC mark.
here.
Design test 1 link art 3D. Link graphic Google like message. Share a picture of your number printed link. Link. Test 1 link art 3D view. Like message. Size 234 x 190 mm.
Yeah.
Size 234 x 190 mm.
So
Like message. Link art menu edit. Enter.
let's edit this.
Maintenance operation schedule for 7. Link channel folded menu. Basic build. Cover max. Move over script. Over script. Like message. 0 0 like 0 0.
And
ZM 0 0 like center position link plus link dash link position right enter. Unscroll link position enter. Unscroll link position enter. Unscroll link position enter. Unscroll link position enter. Unscroll navigation region.
all right. So from here, we'll go to ChatGPT.
Chat enter. Field for enter. Chat GPT.
Okay.
Escape. Chat over script list site control K map. Site guilty map. Enter. Chat.
And
Option.
let me just
Option 1.0. Senior list box. Astro print 5F6. Bamboo 4F. No slot. Browser scene 2F6.
browser.
Virtual PC mark. History. Edit. Reader 80 map. Upload 5. Soap. Navigate. Upload files. Enter. Menu. For menu. Upload 5. Computer enter. For leader PC mark.
Right.
Dialog. Title UI menu. Memories. Title. Control. Start power gadget. Ceremony left. Enter. Still there. Valid. Enter. Chat GPT. Virtual.
Now let's see here.
Folder until top. Enter. Edit. Send.
Please
Please.
describe this 3D object in detail.
Disable.
Do not describe the web interface.
Interface. Virtual.
Let's see what will happen.
Reader over sentence. Max inward. Reader particles left. Over script negotiate chat GPT tag. Circle particles left. Over script negotiate chat GPT tag. Based on the like forever. Based on the sequence of images. Here is a detailed description of the 3D object. Chat GPT like message 1. Base structure. The object is a rectangular platform with a flat bottom and joint stability on the bed. The surface appears to be smooth, possibly. With some engraver embossed details.
All right. So base structure,
1. With some engraver embossed details.
engraved or embossed
2.
details.
Vertical rods slashed in. Several evenly spaced cylindrical rods extend vertically from the base. These rods are lined into parallel rows, creating a grid-like structure.
All right. Several vertically arrayed rods are placed,
3. Rod arrangement. The rods appear uniform in diameter and height and are perpendicular to the base.
and the rods are uniform in length and
Between the rods
perpendicular.
consist 4. Perspective view. One close image. The tops of the rods are visible, showing clean cut with no additional features indicating they might be. Design folders, spacers for guides.
Okay.
5. Side view from a lateral perspective. The object has a narrow profile with the rods forming a repeating pattern. This suggests the object will function as a holder for elongated objects such as tools, cables, or similar items.
So it thinks that this could work as a holder for tools or something like that.
6. Additional features. The object appears to be symmetrical along this single axis, making a balanced design. There are no apparent interlocking mechanisms, hinges, or moving parts.
All right.
Light split.
Sounds about right. Now let's close down this.
Alt 4. Option 1.0. No slot. 3F6. Bamboo 4F6.
And
Windows M. Scribbler. MB enter.
open
Hello.
Bamboo. I gotta wait for that as well because for some strange reason, it also takes time.
Double next web
Well,
view.
not strange
Double next
reason,
web view.
but it's a
DL canvas.
huge program and takes a lot of horsepower, I guess.
Double next web view.
Whatever.
Title Bamboo Studio. Panel.
All right.
Flip on PC. Prepare preview. Device. EV.
I'm just gonna check my device.
Device panel. Flip on PC. SM Lab. Prepare preview.
Yeah.
Prepare. RE.
Click the prepare.
Prepare. Flip on
I'm gonna
panel. Flip on
just
Project 0. Layer I 0. Layer I 0. Left built with attention with initial layer I 0. Blank. 0. 2. Comma. Edit 0. PC.
sync my
Panel. Map. To map. Generic. Bamboo. Panel. Map for map. Map. Enter. Single image.
Yes.
Enter. Untitled Bamboo Studio.
I always do this
Resync. Enter.
just to make sure that everything is in working order and all is working
Control
well.
Kill them.
All right.
Still there. 80 valve door bottom part 2. 1 F 11. Controller. Start power gadget. Enter. Map is infill. Test 9 F9.
I'm going to
Enter.
do
Untitled Bamboo Studio.
this.
Control map for active your level 14%. Loading dot dialog. Panel.
And
Flip on PC. 1 F Bamboo PC. PCF. Process global map object. Snap of 0.2 mm strength. DPL X1C. Quality. X1C. At DPL.
I'm going to use this
Test canvas. 0.2.
profile
0.2 mm. Enter.
to
Panel.
make it a bit more strong.
Test canvas. DL canvas.
All right. And I will do
DL canvas.
this and this. Also like this. And
Fill and collision volume. 1 FM process global 0. Quality strength speed support. Layer. Height. Layer. Others. Support. Speed. Support. Speed. E.
all right.
Support. UP.
Now suddenly speed has
Panel.
been available to me. That's
Strength.
good.
Speed. Support. Others.
Believe me or not, this is the first time I see that I'm able to find speed with my screen reader. So that's awesome. We got to check that out later.
D. R. S. Blank. 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 Support. PC marker. Map for active level.
Enable support. 3D support, and hit Control R.
DL canvas.
It's slicing. Now I'm gonna start the print and let's see how much time this will take. I'm printing this in PETG CF. I really love that. It gives a nice finish, nice touch. Let's see here.
Dialog. 6H56M 233
Oy.
Flip dot. Send print dot test. 6H56M 233 6H56M 233 74 G PETG dash CF A1.
All right, it takes about 6 hours.
CF dash PETG 233 74.
All right.
Easy mark.
Well, we'll see.
Click here. You can send.
And this is why.
Enter. Send print dot dialog. Warning dialog. Please check the cancel. Panel. Confirm. Enter.
Enter.
System Studio.
This is why, you know, I haven't really had anyone check this or
32%.
view it or help me with this. So this is basically my
100%.
workflow where I rely
System Studio.
solely on my own like skills, the help of AI to troubleshoot, give me tips and tricks, descriptions, and that's it. Now we will see how this goes. I will show it off to you and we'll talk about it.
Alt F4. Canvas Studio. Save type.
Let me close down this.
Enter. System Studio. Panel. Panel. The star modified enter.
Start.
System Studio. Option 1.0.1 problem.
And we'll see how it turns out in about 6 hours.
Editor stock.
That's a long time.
Limiter. See loaded. There edit. Filter set. Siren. Stop optical checkbox marker. For enter. See optical stop off. Stop optical checkbox marker. For travel marker. See optical stop off checkbox CD marker. Start virtual camera checkbox CD marker. See stop optical checkbox marker. For enter. Millennium. Stop optical dialog. Net. John app. For active.
All right, so after 6 hours and 200 and something grams of filament, this kitchen board organizer is actually finished. Now, I haven't really used any, I didn't take any kitchen boards or anything like that to demonstrate, but you can clearly see what it is. So we have 1, 2, 3, 4, 5, 6, 7, as I initially intended, 7 rods, where you have a space of a couple of centimeters, not a couple, like maybe a centimeter and a half, 2, something like that in between, which is also what I aimed for. You have these rods, they're 8 centimeters, 80 millimeters tall. Then you have the name Edis written, which is pretty tactily nice. It's a bit huge, but you know, I tried to you know, make it a little bit bigger so that you really can see how I'm doing this. Then you have these nice rounded corners, which is very good. I could have done so that the edges were a bit more filleted, a bit more nice. I'll try to do that in the next version. Now, one thing that's missing are the chamfers at the bottom, and that's one of the things that are so difficult when doing this, because to visually inspect it along the way, well, I'm not able to do that, of course, not in the sense that you can do it when you're working with something and you're sighted. So yeah, that I think is a pretty good result. It's pretty nice. It's yeah, it's a pretty good demonstration of how long it takes for me to make something like this, and it's not even, I mean, it's pretty damn close to what I intended, but it's still not like 100%. So I hope it gives you an idea of the difficulties of 3D designing and printing, but nevertheless, I really love this. So the OpenSCAD, now I will correct the code to include the chamfers, and you'll be able to download it and use it however you want for free. Of course, everything is for free. Yeah, I hope you liked the video. Share it, like it, all that good stuff, and I'll see you on Wednesday with a new video. Cheers and take care.